Hi, welcome back. Advanced Math, Unit 12 on Vectors, Part B, page 3. More examples. So number 2 here, I've got given vector u, so I've got this arrow that represents the vector, and I want to sketch negative 3u in the box. So I'm going to use a slightly different technique for this one than I did on the previous page. I'm going to construct 3u in the negative direction. So the negative 3u means that I'm going to be using vectors that go in the direction opposite the one that's shown here. All right, that's a little better. So you notice I've recreated um, this vector here, but in the opposite direction and about the same length. And that's a negative u vector. And I'm going to do two more, sort of head to tail, same direction, about the same length. There's another negative u. And then here's another one. There's another negative u. So altogether, I've got three negative u's all added together. So that's what a negative 3u vector looks like. And I'm using that to sort of construct my answer. My actual answer, I'm going to do separately. And this is qualitative, I'm eyeballing. I'm looking at this overall vector here, its length, its direction, and I'm trying to reproduce it in its entirety as one single vector over here on the right. And once I've done that, I'm going to label it. It's negative 3u. And that really ugly thing that I put on top of the u is my representation of an arrow. It's not very good. So that's negative 3u. Now, we're going to use that. So you'll notice on this next example here, I've got a u vector again, and it's exactly like the u vector I did here. And I'm trying to figure out what the vector v minus 3u is here. Now, I've already constructed a minus 3u over here. That's minus 3u. I just noticed my u looks like a w, but this is a u with a tail on the end of it. Anyway, um, and I've got a v here. So I'm going to add this vector v to a copy of this negative 3u, and I'm going to add them by doing the head to tail method. So let's start with a v vector. Now I have to kind of plan ahead to think about where this is all going to go. So I'm going to start over here. Here's my v vector, and then I'm going to make a copy of the negative 3u, and I'm going to start it at the head of the v vector. Obviously, I can't be super precise here. I'm eyeballing this. So there's my negative 3. I'm going to make a little more careful on my u. Okay, that's a nicer u. That's a nice u. So those are two vectors uh, that I'm using to construct this sum here. The actual answer, the resulting vector, is the one that starts where the first one started. I'll use a different color. Starts where the first one started and ends where the last one ended. So it's exactly the right length to fit in between those two, the beginning and the end. And it's got that direction. So that is the v minus 3u vector answer. That is what happens when you subtract 3u from v. Okay. Now this is just a really introduction to the next part of this classwork. You may have noticed at this point that we're doing some graphical things, and you're probably thinking to yourself, well, this isn't very mathematical. We're just drawing pictures. What could this possibly mean? And you're right. When we work with vectors in general, we want to use numbers, and so we have to have a system for figuring that out. And this is where we're going to start. So we've got a vector drawn u here, like that. And any vector, if you draw it on a coordinate plane, you can think of that vector as being the sum of two components. And the components have to be parallel to the x-axis. So we'll call this component ux. And another component that's parallel to the y-axis. So we'll call this component uy. And you can see the way I've drawn ux and uy. Those are two vectors. They happen to be parallel to the x and y axes respectively. And they're drawn in such a way so that they add up. They're head to tail. And what they add up to is vector u. So we can say finally that vector u is equal to the sum of its x parallel and y parallel components, ux and uy. And that's going to be really important. And you're going to see in a moment what this all has to do with trigonometry. This vector stuff ties in with trigonometry so beautifully. Okay, that's next page.